What if the most spectacular celestial event in a decade was a lie? In early 2020, a comet named Atlas was on track to become a generational spectacle, a beacon in the night sky. But then, it shattered into pieces and vanished. The official story is that it was just a fragile ball of ice. But the truth is far weirder. Its disintegration was a clue that points to a much larger mystery involving strange visitors and uncomfortable questions that one Harvard astronomer insists we can no longer ignore. Let's explore this together.
Comet Atlas Mystery.
Let's start with the comet that promised everything and then disappeared, C/2019 Y4, or Atlas. Discovered on December 28, 2019 by the Asteroid Terrestrial Impact Last Alert System, this comet initially caused a frenzy. Its brightness was increasing at an astonishing rate, leading astronomers to predict it could reach a magnitude of -5 by May 2020, potentially becoming as bright as Venus and visible during the day. But then, in early April, something went wrong. Instead of brightening, it stalled and then began to fade rapidly. Astronomer Quanji Ye of the University of Maryland led a team using the Hubble Space Telescope to get a closer look. On April 20th, Hubble revealed the truth. The comet's nucleus had shattered into a trail of more than 24 small, icy fragments, some no larger than a house. A second fragmentation event was observed just 3 days later. Interestingly, astronomers calculated its orbit to be nearly identical to the Great Comet of 1844, suggesting both Atlas and the 1844 comet are fragments of a much larger parent body that broke apart some 5,000 years ago as it passed the Sun. The sudden and catastrophic breakup of Atlas served as a stark reminder of how volatile and unpredictable these cosmic visitors can be.
The wow signal.
Before we saw comets disintegrate, we heard a sound we couldn't explain. Think about this. On August 15, 1977, astronomer Jerry R. Amon was using Ohio State University's Big Ear radio telescope when he detected a signal so powerful and so unusual that he circled its alphanumeric code 6EQUJ5 on the printout and wrote, "Wow." The signal lasted for 72 seconds, perfectly matching the time the telescope's beam was aimed at that specific patch of sky, indicating a fixed source. It was an extremely narrow-band signal at a frequency of 1420.4556 MHz, just a fraction away from the natural hydrogen line, a frequency many scientists, including Carl Sagan, theorized an advanced civilization would use. The signal was incredibly strong, peaking at over 30 times the background noise of deep space. Despite decades of searching by researchers like Robert Gray, who's conducted multiple follow-up surveys with more advanced equipment, we have never detected it again. Astronomer Antonio Paris later proposed the signal could have come from a comet's hydrogen cloud, but this was widely refuted, as comets don't emit such strong, narrow-band signals. The WOW signal remains the single most compelling piece of evidence for a potential extraterrestrial intelligence.
Meet Avi Loeb.
So, who has the courage to connect these dots? Enter Avi Loeb. He isn't some fringe theorist, he's a theoretical physicist and the former chair of Harvard's astronomy department, a position he held for a record 9 years. As the founding director of Harvard's Black Hole Initiative and chair of the advisory committee for the Breakthrough Starshot Initiative, he is deeply immersed in the most advanced concepts in physics. He approaches cosmic mysteries like a detective, arguing that we must follow the evidence, no matter how uncomfortable the conclusion. In his book, Extraterrestrial, he makes the case that clinging to familiar explanations for cosmic anomalies is a failure of imagination. He criticizes what he calls an intellectual lockdown in academia, which prioritizes consensus over exploring anomalies. Through his Galileo project, he now aims to build a network of advanced telescopes and AI algorithms to systematically search for extraterrestrial artifacts. This initiative aims to take the study of UAP out of the hands of government and into the realm of transparent, open science, ensuring the next strange visitor doesn't get away without a high-resolution photo.
Oumuamua, discovered.
While Comet Atlas was a visitor from our own distant Oort cloud, another visitor came from much farther away and, well, broke all the rules. On October 19, 2017, astronomer Robert Warwick, using the Pan-STARRS 1 telescope, spotted something totally unprecedented. An object, designated 1I/2017 U1 and named Oumuamua, which is Hawaiian for a messenger from afar arriving first. Its trajectory was hyperbolic, meaning it was moving at a blistering 26.33 kilometers per second, or nearly 60,000 miles per hour, relative to the Sun, far too fast to be captured by our Sun's gravity. For comparison, our fastest departing spacecraft, Voyager 1, travels at only about 17 kilometers per second. It had already made its closest approach to the Sun on September 9th and was discovered on its way out, about 33 million kilometers from Earth. By January 2018, it had faded beyond the reach of even the Hubble Space Telescope. Its dark, reddish color was similar to objects in the outer solar system, but its journey through interstellar space should have changed its surface composition. The discovery of this unique object, the first of its kind, hinted that the galaxy was sending us messages we were only just beginning to see.
Strange behavior.
Here's where things get really bizarre. As Oumuamua passed the Sun, it did something that honestly defied physics as we know it for a natural object. It accelerated. A team led by astronomer Marco Micheli of the European Space Agency confirmed a slight but persistent push away from the Sun, causing it to deviate from its expected path by over 40,000 kilometers. This is normal for comets, but as confirmed by astronomer Karen Meach's team, Oumuamua had no tail. The Spitzer Space Telescope stared at it, setting some pretty stringent limits that ruled out outgassing of carbon-based molecules down to just a few kilograms per second, which is far too little to explain the observed acceleration. On top of that, its shape was extreme. As it tumbled every 7.7 hours, its brightness changed by a factor of 10, a ratio unseen in any of the hundreds of thousands of objects in our solar system. This implied it was either cigar-shaped or, more likely, a flat, pancake-like object no more than a few millimeters thick. Comet expert Zdenek Sekanina proposed it could be a fragment from a larger body, but this still doesn't explain the complete lack of a coma or its extreme proportions.
Light sail theory.
When the data doesn't fit the theory, you need a new theory. Avi Loeb, along with his colleague Shmuel Bialy, published a paper that sent shockwaves through the astronomy world. They proposed the most straightforward, yet most profound explanation. Oumuamua was an artifact of an alien civilization. They argued its acceleration could be explained by solar radiation pressure, sunlight itself pushing it. For this to work, the object would have to be incredibly thin, like a sail. A light sail. This idea was bolstered by the 2020 discovery of 2020 SO, which turned out to be the 10-meter-long Centaur rocket booster from the 1966 Surveyor 2 mission, a known man-made object showing similar acceleration. While other scientists like Alan Jackson and Steve Desch proposed Oumuamua could be a nitrogen iceberg chipped off a Pluto-like exoplanet, Loeb argues that such an object would have sublimated away over its long interstellar journey. Furthermore, a nitrogenberg would have to originate from a very specific and rare type of exoplanet system, making it a highly improbable explanation. The light sail theory remains the only one that elegantly explains all of Oumuamua's anomalies.
Universe age debate.
You know, the weirdness isn't just with visitors, it's really baked into the fabric of the universe itself. For decades we've relied on the standard lambda CDM model, which has told us the universe is about 13.8 billion years old. But, oh boy, the James Webb Space Telescope is now challenging that notion. Under the guidance of senior project scientists like John C. Mather, the JWST is finding galaxies at a redshift of Z greater than 10. This means we see them as they were just 300 to 400 million years after the Big Bang. A team led by Rohan Naidu of the Harvard-Smithsonian Center for Astrophysics has identified candidates like Glass Z Terene. These galaxies appear far too massive and mature for their age. Current models of galaxy formation require billions of years of mergers and star formation to reach that level of complexity. So, these findings have led some scientists, like Rajendra Gupta, to propose that the universe might actually be 26.7 billion years old. His model incorporates the tired light hypothesis, which suggests that light loses energy over cosmic distances. While this idea is controversial, the fact that JWST is forcing a re-evaluation of our most fundamental cosmological model is, well, a scientific revolution in itself. A much older universe would make the idea of ancient spacefaring civilization seem far more plausible, wouldn't it?
NASA spy agency.
While we look to the stars for answers, there are plenty of mysteries right here on Earth. In 2018, Executive Order 13849 from the Trump administration quietly reclassified some of NASA's functions. What's the real story? NASA Watch founder Keith Cowing pointed out that the order's primary purpose was likely related to labor laws. However, it's naive to think NASA doesn't have a national security role. They frequently launch satellites for the National Reconnaissance Office, or NRO, the agency whose very existence was classified until 1992. This collaboration dates back to the Cold War with programs like the Manned Orbiting Laboratory, or MOL, a secret Air Force space station that used NASA-like hardware for surveillance. This blurring of lines creates public skepticism. When the government is known to keep secrets about space technology, it makes it harder for the public to trust official explanations for unusual phenomena like UAPs or strange comets. It fosters a climate where extraordinary claims can feel more plausible than official denials.
Interstellar visitors.
The discovery of comets like Atlas is becoming more common, and these same automated sky surveys are now finding interstellar objects. On August 30, 2019, amateur astronomer Gennady Borisov discovered our second interstellar visitor, 2I Borisov. It was moving at a blistering 32 kilometers per second and had a massive coma and tail. Spectroscopic analysis by a team led by Dennis Bodowitz of Auburn University revealed an unusually high abundance of carbon monoxide, at least 9 to 26 times higher than typical solar system comets. This suggests it formed in a very cold, carbon-rich environment far from its parent star, a region analogous to our Kuiper Belt but perhaps even colder. With a nucleus of only about 1 kilometer, its normal cometary behavior was crucial. It provided a perfect baseline that showed us what a natural interstellar object looks like. By contrasting it with Oumuamua, it only made the first visitor seem stranger. As planetary scientist David Jewett has calculated, there could be thousands of these objects passing through our solar system at any given time, most too small and dark for us to see.
Humanity and war.
If we do have cosmic neighbors, what would they think of us? This brings us to a chilling story from March 13, 1975. A pilot named Carlos Antonio de los Santos Montiel, flying a Piper PA-24 Comanche near Mexico City, reported his plane was flanked by 3 UFOs. He claimed to have received a telepathic warning. Humans are one of the only species in the universe that still engages in war. This touches on the Great Filter Hypothesis, popularized by Nick Bostrom, and the Kardashev Scale, developed by Soviet astronomer Nikolai Kardashev, which classifies civilizations by energy use. A species that can't move beyond internal conflict, or a Type 0 civilization like ours, would likely never reach Type 1 status. The Doomsday Clock, maintained by the Bulletin of the Atomic Scientists since 1947, is a real-world metric of this danger. Perhaps advanced civilizations operate under a non-interference policy with volatile species. This would frame our global conflicts not just as a human problem, but as a potential cosmic barrier preventing our entry into a galactic community. From the broken promise of Comet Atlas to a mysterious signal from the stars, the evidence is mounting that our universe is far stranger than we imagine. The story of Atlas reminds us how much we still have to learn, while the puzzle of Oumuamua, championed by the brilliant and brave Avi Loeb, forces us to confront the possibility that we have been visited. It's a cosmic detective story where the clues point to a conclusion that is both terrifying and exhilarating. Are we on the verge of the greatest discovery in human history? The universe is speaking to us. The only question is whether we are ready to listen. Thank you for joining us on Space Facts. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the mysteries of our cosmos. See you next time. Thanks for watching Space Facts. What if a message from the stars wasn't a radio wave, but a silent flash of light speaking the oldest language in the universe? On October 13, 2025, an interstellar object, thought to be long gone, sent a signal that defied all known physics. It wasn't random noise. It was a mathematical pattern, the same one that shapes galaxies and life itself, detected by 2 observatories on opposite sides of the Earth at the exact same moment. Let's explore this together.
The Night of Pulses.
Did the sky blink, or did something blink back? On the night of October 13, 2025, a stunning event unfolded. 2 observatories, one in Chile and one in India, registered a bizarre series of light bursts originating from behind the sun. The source's trajectory matched that of 3I Atlas, an interstellar visitor that had vanished from view weeks earlier. This wasn't just a random flicker. The pulses were rhythmic and structured, The event immediately brought to mind the work of Harvard astronomer Avi Loeb, who has argued that we must be open to the possibility of extraterrestrial technology. Loeb even proposed a scale where 0 is a purely natural object and higher values suggest artificial origins. The behavior of 3I Atlas was so precise it would have scored high on that scale. The flashes were faint but distinct, organized into 3 groups with mathematically significant intervals. At a magnitude of +22, these pulses were at the very edge of what even powerful observatories can detect, requiring long exposure imaging to even register. For such a weak signal to be so clearly structured with a high signal-to-noise ratio was extraordinary, suggesting its origin was something other than chaotic natural processes.
Fibonacci sequence.
Is there a language any intelligence in the universe would understand? The answer is mathematics, and the pulses from 3I Atlas used one of its most elegant dialects. The intervals between the bursts were precisely 5, 8, and 13 seconds. This isn't a random set of numbers, it's a core section of the Fibonacci sequence. 0, 1, 1, 2, 3, 5, 8, 13, the famous pattern where each number is the sum of the two preceding it. First introduced to the Western world by the Italian mathematician Leonardo of Pisa in his 1202 book Liber Abaci, this sequence is nature's architectural blueprint. It appears in the spiral arms of the M51 Whirlpool galaxy and governs the principle of phyllotaxis, the arrangement of leaves on a plant stem, which often follows Fibonacci ratios to maximize sun exposure. The 19th century mathematician Edward Lucas, who gave the sequence its modern name, studied its properties extensively. The use of this sequence suggests a message designed to be universally recognizable as non-random and biological or structural in nature. For an interstellar object to emit signals matching this pattern was profoundly strange. It was as if it was broadcasting a page from the universe's own design manual.
Double confirmation.
How do you turn a strange anomaly into hard data? You need independent confirmation, and that's exactly what made the 3I Atlas event impossible to dismiss. The Cerro Tololo Inter-American Observatory in Chile and the Mount Abu Infrared Observatory in India, separated by nearly 12,500 kilometers, both recorded the identical pulse sequence. The recordings occurred within the same 1-minute window, starting at 2:41 UTC. This is critical. They used entirely different instruments, one optical, one infrared, and operated on separate tracking systems. The photometric sensors at Cerro Tololo captured the peaks at 2:41:13, 2:41:18, and 2:41:31 UTC. Mirrored spikes appeared in Mount Abu's infrared data with a synchronization of 0.04 seconds. Frank Drake, creator of the famous Drake equation, always emphasized that signal verification is paramount. Potential false positives like atmospheric scintillation, satellite glints, or cosmic ray hits on the CCD sensors were systematically ruled out. The statistical odds of two observatories experiencing an identical complex instrumental error were calculated to be less than 1 in 10 billion. This double detection transformed the event from a potential glitch into a verified phenomenon.
The golden ratio.
What if the message was not just in the timing, but in the light itself? The Fibonacci sequence is directly linked to another fundamental constant, the golden ratio, an irrational number that's approximately equal to 1.618, also known as phi. Back in the 17th century, the astronomer Johannes Kepler marveled at these divine proportions, believing they revealed the universe's geometric harmony. Now, analysis of the 3I/Atlas pulses showed its light wasn't just blinking. Its peak brightness actually scaled with each pulse. The intensity of the second pulse was roughly 1.6 times that of the first, and the third scaled similarly, matching the progression of phi. The physicist Roger Penrose has shown this ratio appears in fundamental physics and the geometry of space-time. To produce such a signal would require a mechanism capable of precise energy modulation, which is, honestly, far beyond random reflections off an asteroid. The energy distribution of the pulses also matched a logarithmic spiral, a form found everywhere from nautilus shells to the arms of hurricanes. This precise scaling across distance, frequency, and intensity simply could not be a random reflection. It had to be intentionally modulated.
The Fatima anniversary.
Could the timing of the signal be as significant as the signal itself? The pulses were detected on October 13, 2025. That date, interestingly, marked the 108th anniversary of the miracle of the sun at Fatima, Portugal. On October 13, 1917, a crowd estimated between 30,000 and 100,000 people claimed to witness the sun dance, spin, and emit brilliant colors. The physicist August Meessen of the Catholic University of Leuven proposed a scientific hypothesis for the event, suggesting a rare solar mirage amplified by retinal distortion. Regardless of the cause, the event is etched in cultural memory. The Condon Report of 1968, which studied UFO phenomena, noted that such mass sightings often have conventional explanations, but the cultural impact remains powerful. The parallel is, really, undeniable. On the exact same day, over a century apart, two events occurred involving a celestial body performing impossible light maneuvers. This bizarre historical echo transformed a scientific mystery into something deeply symbolic, linking a modern signal to a century-old miracle, and forcing even skeptical minds to acknowledge the depth of the coincidence.
NASA's blackout.
When the most powerful eyes on the sky suddenly go dark, you have to ask why. Just hours before the 3I/Atlas pulses were detected, NASA's Solar Dynamics Observatory, or SDO, went offline for scheduled maintenance. The SDO is a workhorse, capturing an image of the sun every 12 seconds, across 10 different wavelengths, and generating nearly 1.5 terabytes of data daily. For it to go dark during such a critical window is, honestly, highly suspicious. Compounding this, the high-rise camera on the Mars Reconnaissance Orbiter, which can resolve objects down to 30 centimeters on Mars, had been inactive since October 1st. Nicola Fox, the head of NASA's Heliophysics division, oversees these missions. The official explanation cited routine calibration overlaps, but for two premier systems to be down simultaneously felt, to many, too convenient. The SDO's atmospheric imaging assembly, in particular, would have been the perfect instrument to confirm or debunk the pulses directly. Its absence created an unfillable data gap, fueling speculation that this was not maintenance, but a deliberate blackout.
Harmonic resonance.
What if the signal wasn't just a message, but, an activation key? The numbers 5, 8, and 13 might be more than just a sequence. They could correspond to frequencies. The concept of orbital resonance is actually a well-established principle in astrophysics. A prime example is the 1 to 2 to 4 resonance of Jupiter's moons Ganymede, Europa, and Io, which was studied by Pierre-Simon Laplace way back in the 18th century. Another example is the Kirkwood gaps in the asteroid belt, those empty regions caused by Jupiter's resonant gravitational pull. Modern celestial mechanics expert Renu Malhotra has even used these principles to predict the structure of the Kuiper belt. So, one interpretation of the 3I Atlas signal is that it wasn't aimed at our eyes, but at the solar system itself. The pulses, with their precise timing, could have been designed to resonate with key gravitational zones, the 5th harmonic with Earth's orbit, the 8th with the asteroid belt, and the 13th with Jupiter's influence. This would be a form of communication that uses the very architecture of spacetime as its medium, transferring information through gravitational vibrations.
The Dante connection.
Could a 700-year-old poem hold a clue to an interstellar message? In the 14th century, the Italian poet Dante Alighieri wrote Paradiso. In it, he describes heaven as 9 concentric celestial spheres, with their structure governed by precise numerical and geometric principles. The year of Dante's death, 1321, is exactly 704 years before the 2025 event. Physicist and Dante scholar Mark A. Peterson published a famous paper in 1979, arguing that Dante's cosmos wasn't just concentric circles, but a hypersphere, the three-dimensional surface of a four-dimensional ball. The rhythm of ascent in Paradiso mirrors patterns of growth similar to the Fibonacci sequence. Now, this isn't to say Dante predicted the signal, but that the mathematical patterns of order and growth are so universal they appear in both our deepest artistic intuitions and in signals from the cosmos. The idea that an interstellar signal in 2025 would use the same sequence is, honestly, staggering. It raises the haunting possibility that this mathematical pattern is a universal signature of intelligent design, an archetype recognized across cultures, centuries, and perhaps even worlds.
Observatories respond.
After a week of intense public speculation, what did the scientists who saw it first have to say? The official statements from both the Cerro Tololo and Mount Abu observatories were masterpieces of scientific caution. They confirmed the data, captured starting at 2:41 UTC, was real. The timestamps were synchronized and the pulses were consistent across optical and near-infrared bands. But they refused to speculate on the origin. The event was labeled a non-repeating transient photometric anomaly. To a SETI researcher like Jill Tarter, this approach is standard procedure. However, their findings were published in low-profile technical bulletins, not major peer-reviewed journals like Nature or the Astrophysical Journal. This was a strategic choice. It places the data on the record for specialists without inviting a media frenzy. Contrast this with the 2016 announcement of the first detection of gravitational waves, which was a major, coordinated press event. The quiet, almost buried release of the 3I Atlas data made it clear that the institutions involved did not want to deal with the public implications of their discovery.
The missing data.
Sometimes, the most important clue is the evidence that isn't there. As researchers and the public scrambled for answers, all eyes turned to NASA, whose silence was deafening. The data from the Solar Dynamics Observatory for the entire period of the 3I Atlas event was missing from the public archives. This was a gap where 1.5 terabytes of crucial solar data should have been. There was no error note, just a void. Edward Tufte, a pioneer in data integrity, teaches that such omissions are often more revealing than the data itself. This silence wasn't limited to NASA. The European Space Agency's solar orbiter issued no comment, despite being in a perfect position to observe. The Japan Aerospace Exploration Agency JAXA also remained quiet. NASA has strict protocols for documenting data gaps from missions like the SDO. The complete absence of such documentation was a major breach of their own standards of transparency. This global information blackout became the smoking gun, transforming the narrative from a scientific puzzle into a potential cover-up. So, what are we left with? An interstellar object emits a structured light signal based on a universal mathematical constant. The event occurs on the anniversary of a famous celestial miracle. It's independently confirmed by 2 observatories, only for the world's leading space agencies to go conveniently blind at that exact moment. Was it an impossibly complex series of coincidences, a natural phenomenon beyond our current understanding, or was it exactly what it looked like? A message? A single, simple greeting written in the language of light and mathematics. We may never know for sure, but the silence from those who might have answers is the most unsettling part of all. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the universe's greatest mysteries. Thanks for watching Space Facts. It started as nothing more than a faint glimmer against the cosmic darkness. Now, the James Webb Space Telescope has captured the first detailed image of 3I Atlas, revealing secrets that challenge everything we thought we knew about visitors from beyond our solar system. What they discovered will change astronomy forever. The flicker in the dark. What began as a subtle anomaly in astronomical data has evolved into one of the most significant discoveries in modern space science. On July 1, 2025, the Atlas telescope in Rio Hurtado, Chile, first detected a mysterious object designated A11PL3Z, initially appearing as nothing more than a faint magnitude 18 point of light moving through the border regions of constellations Serpens Cauda and Sagittarius. Global observatories immediately mobilized, with facilities worldwide turning their instruments toward this enigmatic visitor. The object's unusual motion patterns quickly attracted attention from professional and amateur astronomers alike, sparking an unprecedented international collaboration. Within hours of detection, follow-up observations from the Canada-France-Hawaii Telescope and Lowell Discovery Telescope revealed something extraordinary. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. The discovery observations were rapidly submitted to the International Astronomical Union's Minor Planet Center, but what astronomers found defied conventional expectations. This sudden appearance in our telescopic view marked the beginning of a collective quest to understand what would soon be recognized as humanity's third confirmed interstellar visitor, forever changing our understanding of cosmic wanderers. Beyond the solar veil. How do astronomers definitively prove that an object originated from the vast emptiness between stars? The answer lies in 3I/Atlas's extraordinary orbital characteristics that firmly establish its interstellar origins. Follow-up observations quickly confirmed this wasn't an ordinary solar system resident but a genuine visitor from beyond our cosmic borders. The object follows an extremely hyperbolic trajectory with an orbital eccentricity of 6.141, the highest ever recorded for any confirmed interstellar object. Racing through space at an incredible 58 kilometers per second relative to our Sun, 3I/Atlas moves significantly faster than the previous record holders, 1I/Oumuamua at 26 kilometers per second and 2I/Borisov at 32 kilometers per second. Its trajectory appears almost perfectly straight rather than curved, a telltale signature of an unbound hyperbolic orbit that will carry it back into the depths of interstellar space forever. Researchers worldwide marveled at calculations showing this cosmic wanderer had journeyed across the galaxy for potentially billions of years before entering our solar system. The realization that 3I/Atlas represents authentic material from another star system, possibly formed around a star that died before our Sun was born, has sent shockwaves through the astronomical community and fundamentally expanded our understanding of galactic wanderers. The accelerating mystery. Why does 3I/Atlas exhibit velocity patterns that challenge our understanding of gravitational mechanics? Scientists conducting detailed trajectory analysis discovered that this interstellar visitor displays acceleration characteristics unlike typical comets or asteroids bound to our solar system. While most celestial objects follow predictable paths determined purely by gravitational influences from the Sun and planets, 3I/Atlas demonstrates subtle but measurable deviations from expected trajectories. These anomalous acceleration patterns suggest forces beyond simple gravitational attraction are influencing its motion through space. The object's behavior resembles that of 1I/Oumuamua, which famously displayed mysterious non-gravitational acceleration that baffled scientists and sparked controversial theories about possible artificial origins. Early observations showed 3I/Atlas beginning cometary activity, while still 4.5 astronomical units from the Sun, much farther than typical solar system comets start outgassing. This early activation, combined with its unusual velocity profile, creates an accelerating mystery that challenges conventional models of cometary physics. The combination of extreme speed, hyperbolic trajectory, and anomalous acceleration has forced astronomers to reconsider fundamental assumptions about how interstellar objects behave when passing through foreign star systems, opening new avenues of research into the complex dynamics of cosmic wanderers. Patterns in the void. What does the increasing frequency of interstellar discoveries reveal about our galaxy's hidden population of cosmic wanderers? The detection pattern of interstellar objects has shifted dramatically from theoretical possibility to observable reality in just 8 years. Following the groundbreaking discovery of 1I/Oumuamua in October 2017 and 2I/Borisov in August 2019, the arrival of 3I/Atlas in July 2025 suggests these cosmic travelers are far more common than previously imagined by theoretical models. Statistical analysis indicates that millions of such objects likely pass through the outer solar system undetected each year, with only recent technological advances allowing regular detection of these elusive visitors. The Atlas Survey Network and similar sky monitoring systems have finally reached the sensitivity threshold necessary to spot interstellar objects during their brief passages through our cosmic neighborhood. Each discovery has revealed unique characteristics. Oumuamua appeared asteroid-like with mysterious acceleration. Borisov behaved like a typical comet with visible tail and coma, while 3I/Atlas combines cometary features with unprecedented size and ancient age. This evolving pattern challenges previous galactic models that suggested interstellar objects should be extremely rare, instead revealing a galaxy filled with wandering worlds ejected from distant planetary systems. The rapid succession of discoveries implies we've entered a new era, where studying visitors from other star systems will become routine rather than extraordinary, fundamentally transforming our understanding of galactic dynamics. The machine hypothesis. Could the James Webb Space Telescope's unprecedented imaging capabilities reveal evidence that 3I/Atlas represents advanced technology rather than natural formation? The Space Telescope's revolutionary infrared sensors and massive mirror have captured details of this interstellar visitor that were impossible to obtain with previous instruments. Webb's thermal imaging reveals surface features and material compositions that challenge conventional explanations for natural comet formation. The object's reflective patterns across multiple wavelengths show uniformity inconsistent with typical rocky or icy compositions, suggesting potentially engineered characteristics. Most intriguingly, Webb's sensitive instruments detected structured electromagnetic emissions from 3I Atlas that don't match expected signatures from sublimating ice or outgassing dust. These artificial characteristics have rekindled the machine hypothesis first proposed by Professor Avi Loeb of Harvard University, who previously suggested that Oumuamua might represent extraterrestrial technology. Loeb argues that 3I, Atlas's statistically impossible trajectory through our solar system, combined with its extreme age and unusual properties, suggests possible artificial construction designed for reconnaissance purposes. The telescope's observations reveal thermal properties that appear too stable and controlled for natural processes, hinting at sophisticated materials or construction methods. While most astronomers favor natural explanations, Webb's data continues to fuel ongoing debate about whether humanity has encountered its first confirmed example of extraterrestrial engineering, making 3I Atlas potentially the most significant discovery in human history. Spectral secrets. What hidden information lies encoded in the light signatures captured by humanity's most advanced space telescopes? Advanced spectroscopic analysis by both the James Webb Space Telescope and Hubble Space Telescope has revealed electromagnetic signatures from 3I Atlas that fundamentally challenge our understanding of interstellar object composition. Webb's near-infrared spectroscopy detected water ice, hydroxide ions, and silicate minerals within the object's coma, but also identified spectral features that don't correspond to any known natural materials. The reflectance spectrum shows a complex reddish coloration with specific color indices of G-R equals 0.43 magnitudes and R-I equals 0.16 magnitudes, similar to D-type asteroids but with anomalous absorption lines that suggest exotic chemical compositions. Most puzzling are the electromagnetic fluctuations detected across multiple wavelengths that appear too structured and regular to result from random sublimation processes. Hubble's ultraviolet observations on July 21, 2025, captured unexpected emission signatures that don't match typical cometary outgassing patterns, hinting at non-natural energy sources or material properties. The spectral slope of 1.3% per 100 nanometers indicates surface materials altered by cosmic radiation, yet the object maintains structural integrity, despite its estimated age of over 7 billion years. These spectral secrets invite fundamental reconsideration of how we interpret astronomical data, pushing the boundaries between natural phenomena and potentially engineered materials that could represent technology from advanced civilizations. The information blackout. Why have government agencies suddenly imposed unprecedented restrictions on data sharing regarding 3I/Atlas observations? Despite intense international scientific interest and the collaborative nature of astronomical research, multiple government entities have quietly implemented strict controls over information access surrounding this interstellar visitor. Research teams at major observatories report facing unusual bureaucratic obstacles when attempting to publish certain findings, with specific datasets being classified under national security provisions typically reserved for military applications. The Pentagon's All-Domain Anomaly Resolution Office has reportedly issued guidance restricting public release of detailed trajectory calculations and compositional analysis data. International collaborations that normally share telescope time and observational data freely have encountered coordination difficulties, with some facilities receiving directives to limit foreign access to 3I/Atlas research. Professional astronomers working on the project describe an atmosphere of unusual secrecy, with peer review processes being delayed and certain papers being withdrawn from publication without explanation. NASA and ESA officials have declined to comment on specific restrictions, citing ongoing analysis and security considerations. This information blackout represents a dramatic departure from the open scientific collaboration that characterized previous interstellar object discoveries, fueling speculation about what potentially explosive discoveries might be hidden from public view. The veil of secrecy surrounding 3I/Atlas creates unprecedented tension between scientific transparency and government oversight, raising fundamental questions about who controls access to potentially paradigm-shifting cosmic discoveries. Controlled heat and hidden intent. How could a natural object billions of years old exhibit thermal management systems that suggest intelligent design? James Webb Telescope observations have revealed thermal patterns in 3I/Atlas that, honestly, just defy our conventional understanding of how cosmic objects regulate temperature during solar approach. Rather than heating passively as solar radiation intensity increases, the object actually exhibits sophisticated thermal stabilization that maintains structural integrity through controlled energy distribution. Webb's mid-infrared instrument captured thermal emission spectra showing heat dissipation patterns inconsistent with natural sublimation processes, suggesting, adaptive temperature regulation mechanisms. The object's surface maintains remarkably uniform temperatures across different regions, despite varying solar exposure angles indicating possible internal thermal management systems. Most extraordinarily, 3I/Atlas demonstrates selective heating patterns that appear to prioritize structural preservation over random thermal expansion, behavior that really implies intentional engineering rather than just natural physics. Temperature fluctuations follow mathematical patterns rather than the chaotic thermal dynamics you'd expect from cometary outgassing, with heat distribution appearing optimized for maintaining operational stability. Thermal infrared observations reveal controlled heat signatures that could indicate sophisticated materials science or advanced construction methods designed to survive billion-year journeys through interstellar space. These controlled thermal characteristics suggest hidden intentions beyond simple cosmic wandering, pointing toward potential reconnaissance or scientific mission parameters that would require long-term operational capability. The prime number message. Could mathematical sequences embedded in thermal fluctuations represent the first confirmed extraterrestrial communication attempt in human history? Advanced computer analysis of Webb telescope thermal data has detected numerical patterns within 3I/Atlas's heat emission cycles that correspond to prime number sequences, with mathematical precision that honestly exceeds statistical probability for random occurrence. The sequences appear encoded in temperature fluctuation intervals, following the mathematical progression across multiple observational periods. These prime number patterns emerge from thermal data with statistical significance that, really, rules out coincidental natural processes suggesting deliberate mathematical encoding within the object's thermal behavior. MIT researchers analyzing the data report that the probability of such precise mathematical sequences occurring naturally approaches zero, indicating intentional information encoding. The prime number sequences repeat in cycles corresponding to the object's 16.79-hour rotation period, suggesting systematic transmission rather than random thermal variation. Additional mathematical analysis has identified Fibonacci sequences and other mathematical constants embedded within the thermal signature patterns, implying sophisticated understanding of mathematical concepts that would indicate intelligent origin. The discovery that 3I/Atlas appears to be actively transmitting mathematical information through thermal modulation represents a potential paradigm shift in human understanding of extraterrestrial intelligence and communication methods. If confirmed, these prime number messages would constitute the first verified example of interstellar communication, fundamentally changing humanity's cosmic perspective and confirming that we are not alone in the universe through the universal language of mathematics. The Watchers and the Watched. How has the arrival of 3I/Atlas fundamentally transformed humanity's understanding of our cosmic significance and role in the galaxy? The implications of this interstellar visitor extend far beyond simple astronomical discovery, forcing a complete inversion of humanity's traditional perspective on extraterrestrial contact and cosmic observation. For centuries, humans have positioned ourselves as the observers, scanning the skies, searching for signs of life, and assuming we were the cosmic detectives investigating an empty universe. The potential artificial nature of 3I/Atlas, combined with its apparent mathematical communication attempts, suggests that we have been the subjects of observation rather than the observers. This revelation that advanced civilizations might have been monitoring Earth for thousands of years fundamentally challenges anthropocentric assumptions about human uniqueness and cosmic importance. The object's trajectory through our solar system, timed with humanity's technological advancement and space exploration capabilities, suggests deliberate reconnaissance designed to assess our civilizational development. Professor Avi Loeb theorizes that 3I Atlas represents evidence of a galactic community that has been studying emerging civilizations like humanity, treating us as subjects in a cosmic anthropological study. The mathematical prime number sequences detected in its thermal emissions could represent attempts at first contact using universal mathematical concepts that any technological civilization would recognize. This paradigmatic shift from watchers to watched forces humanity to reconsider our cosmic role, our readiness for interstellar contact, and the profound implications of discovering that we have been under observation by intelligences far more advanced than our own, fundamentally redefining our place in the cosmic hierarchy. As 3I Atlas continues its journey through our solar system, carrying its mathematical messages and thermal secrets, humanity stands at the threshold of the most profound discovery in our history. The James Webb Telescope has shown us that we are not alone, and perhaps never were. For more groundbreaking space revelations that challenge everything we know about the universe, stay tuned to Space Facts.